Okay, so stat test, we're at A. So we have three things that we have to put in here: X, N, and confidence level. What is our confidence level? 0.95. What is our N? 50. What is our X? How do you find 7? So usually problems give us X and N.
What is X?
Number of successes.
It's our p-hat.
Usually it gives us this one and this one. But this one gives us this one and this one. So can we just do math to figure out what X is? So what is 14% of 50 is how you figure out how many successes you have. You could like type that in there. Yeah, so actually as X, you could type in 0.14.
What did that? It said error. Oh, never mind. I didn't do that.
So just showing you that if it gives you a p-hat, it can give you that. Using your calculator is still fine. So we end up getting, and I don't remember what this is, we get a lower bound of what? Which is less than or equal to, which is less than or equal to. All right, so in number 2, so in number 1, my whole point was if I give you p-hat, know how to solve the problem, even if you use a calculator.
So our X is the p-hat.
No. So X is number of successes. So I'm using this equation right here. If I were using this one, my p-hat was 0.14. Okay. So to get that, I'm going to plug. Alright, so in number 2, this is one that, just a reminder, you need to know how to do this. If I give you a z-score, ask you to find a z-score. How do I know it's z-score and not t for this? Because we're doing proportions. It's the only reason I referenced that problem. That is not on your purple sheet. I don't think 86 is on there. I guess I should double check that. 86 is not one, right? Okay. So just remembering, you need to know that quick process of how to get there just in case. So what would I do here? 1 minus 0.86. So how much is in each tail? So I did 100 minus 86, which gave me 14%. 14 divided by 2 gave me 7%. And that's what's in the tail of what I look up in the Z table. And you get what? Now, I wouldn't expect to see a problem like that often, but because it comes up so rare, people forget how to do it.
Wait, so you look at your
Yellow in the middle for the closest thing to 0.0700. Because we're doing Z, it's just not one that we can cheat and do it on our T.
Whenever they're not the same distance apart, you just take whichever one's
All right, now I'm going to show you how to do these in your calculator. Just like before, some of you will choose to do it and some of you will not. Hit second distribution. So second distribution uses our yellow sheet in our calculator, right? Usually, if we want to use the yellow sheet in the calculator, which button do we push from here? Normal CDF. But we're not, that's if we want to find an area. But now we want to find a z-score. So instead, we're using number 3, which is inverse norm, which gives you this. Well, on a z chart, if I'm drawing the curve for a z, the middle is at what? 0. That's why mu equals 0. And 1 away each way is the standard deviation. So 0 and 1 stay the same always.
What are you doing?
I'm just doing what you just did in the calculator.
Okay, so it's second distribution and then what?
3, inverse norm. Now, which area did you just look for in your yellow sheet? Physically, number did you look for in your yellow sheet? 0.07. So if I do this, this is telling me do what I just did on my paper for me. Oops. Which is going to give you the same 1.48 that you just found. And again, some of you will choose to do that and some of you will not. I do not care either way.
How do you know why are you doing your mu 0?
That stays the same always because when you draw your curve, it's centered at 0 with 1 each way. And this works the same with inverse t as well. Just while I'm here, let's say we're doing one with 90%. What t is 90% with an n of 14. So if you go to second distribution, inverse t, the only thing it prompts you for is area and degrees of freedom. So I still have to think through this part again. So if 90% is in the middle, how much is in each tail? 0.05. What would my degrees of freedom be if my n is 14? 13.
So inverse normal is when we're doing inverse t?
Yes, and inverse t is with t. And that way you could find your t the same kind of way.
Could we do that for the values that aren't with the
Ones you have to estimate for because they're not on the sheet?
Yeah.
Mm-hmm. And I would accept the conservative answer from your worksheet or that exact one using your calculator. So again, I'm showing you these so that some people will choose to use them, and I understand that some people won't and some people will, and I do not care.
And if it's negative, we don't.
So when you look it up, it's negative, but the star means that I'm doing plus minus, and that's why we just kind of ignore it. Yeah. All right, and then one last one of these I want to do. Write this one down. This is the last one I want to write down on this paper to do. Clearly, I just made up this problem. So this is one of those that we started out with, and you guys were asking me questions about, do I need to answer this part? And I was like, yeah, but not yet. I just didn't want to focus on this part of it yet. So this is usually when the question asks you an actual question, like, what do you think about this? Or do you think this would work? That kind of thing. So this is saying I've done the entire 4-step, and I did want to show you, sometimes they'll write the answer like this, and that's your lower bound, upper bound. So in absolutely no way, it doesn't really ask it there. In absolutely no way do you need to draw this, but I think it makes sense when I'm explaining it. I know that I'm dealing with a 90%, so I'm saying I'm 90% of the samples will be between here and here. What is the store claiming? Where is this? Where is this on my graph? Where is it not on my graph? In my confidence interval. Does it matter that it's close? It either is or it isn't. So if I were arguing with someone about this, is it saying it's impossible for that to happen? How likely would it be for that to actually be the mu? Use this.
5%.
And not exactly 5%, but
Less than that.
What's the question?
if I'm saying something like, am I saying that I was trying not to type much so y'all don't have to write stuff down. The question would be, is their claim true, or could their claim be true, or something like that? Are they right? So if this were asked in a question, we'd probably say something like, this doesn't seem reasonable because there's a less than 5% chance that would actually be the case. So do you understand how to, now if I said, if they claimed for it to be 5.6, what would your answer be? Yes, that is reasonable. It falls within our confidence interval. So even though I'm not writing up a question there, do you understand how you can answer something applied to a confidence interval? And then you can use percents to justify it if it's outside of it.